Welcome to Facts for Real videos. Today I will share with you how strong would be a black hole the size of a coin. The most dangerous, strange, and fascinating objects in the universe are black holes. It is always hungry, eating everything in its path and continually expanding. So how small or large can a black hole be? Let's find out why it's not very common for a black hole to be born. They're just a byproduct of a huge star concluding its life cycle. If you take a star and squeeze it very hard at some time, it will break. It can no longer sustain the pressure. As a result, it collapses and becomes a black hole. For example, by shrinking, we can produce a black hole, squeezing the sun to roughly 1.8 miles. In the end, the Earth will shrink to the size of a pea. Unlike stars and planets, we get a strange dark object with incredible mass and gravity. There are no size constraints for black holes. They grow by eating the materials around them. But how much do their sizes differ? They can, for example, hypothetically be incredibly small. Indeed, black holes with diameters of 1 atom or smaller are possible. These are known as primordial black holes. They may or may not exist, and if they do, they are most likely the universe's earliest objects, possibly older than the atoms themselves. These would have formed a long time after the Great Bang, when the universe was still extremely dense. It had a lot of energy and felt like a boiling broth. A black hole might be formed by any particle that was somewhat denser than its neighbors, and the smallest of them would still weigh trillions of pounds. Those the size of atoms would weigh as much as a large mountain, while those the size of the Earth may be a little larger than a penny. But even if they exist, the temperature inside them would be rather innocuous. That is many times hotter than our sun. As a result, they would vanish rapidly after birth. Let's look at the black holes now. We know and have seen the first ones, which are commonly referred to as stellar black holes. They weigh tens of solar masses, which does not appear to be much at first. Don't even try to imagine the weight of the sun, which weighs 9 million pounds. This number contains 30 zeros. The tiniest black hole known to humanity is around 2 to 4 times heavier than the sun. It's a lonely hole that wanders across space looking for prey. The one closest to us is known as Gaia BH1. It weighs around 10 times more than the sun and can reach distances of several miles, the furthest of which is known as M33/7. It's around 3 million light-years distant from us right now. It's devouring a blue monster several times the size of our sun. Let's now go on to the so-called intermediate mass black holes. You can tell that he is just consuming a few. Stars are insufficient to increase the size of black. Black holes must either absorb a large number of stars or, more commonly, combine with another black hole. This is how one of the first intermediate mass black holes we discovered was born. It is 142 times heavier than the sun. It's even greater than certain counties on Earth recently. One day, we detected 2 black holes in a galaxy 17 billion light-years away. They will eventually unite, but not right now. These guys are spinning around each other in a frantic dance and releasing an insane amount of energy, which may appear frightening. But it pales in comparison to what follows. Let's get down to business. Supermassive black holes are unfathomable beasts millions of billions of times larger and heavier than our sun. But how did they grow to be so massive? The cosmos is around 14 billion years old, and black holes formed slowly. As a result, they couldn't eat so much matter or integrate with each other so quickly that it's possible. They were likewise created by the stars, but very large ones that are quasi-stars. Let us consider their scale. Consider the red supergiant Stephenson 218. In comparison to this star, our sun is a grain of sand even smaller, and Stephenson 218 is a grain of sand near to an unknown quasi-star. If they truly existed, they could have originated after the creation of the cosmos. They could be so massive that their core collapsed under their own weight before they formed. And if that's the case, a small black hole would have formed in the center of this quasi-star, and the frenzied gravity of the black hole would have held the star together while eating it at the same time. The temperatures were enormous. Therefore, the star stayed constant, and they lived in this manner for millions of years till the black hole would expand to monstrous proportions. The majority of supermassive black holes are found in galaxies' centers. You might believe that our galaxies orbit them in the same way that we orbit the sun, and that one day we'll all be pulled inside eventually. So don't worry, despite their enormous size, this is not the case. They're not very enormous in diameter. They cannot, for example, devour entire galaxies at the heart of our Milky Way. Sagittarius is a black hole with 4 million solar masses, but it is still quite small, only 17 times larger than the sun, and yes, it is still regarded small. it would not have reached if we had replaced the Sun with this black hole. Mercury's Sagittarius orbit is actually quite pleasant and quiet. Yes, it still consumes massive stars, yet it poses no danger to humans. But not all of them are like that. A massive amount of gas and dust being devoured by a black hole in the galaxy BL Lassert. If we were close enough, it would appear to be 115 times larger than the Sun, and we'd have burned up simply getting near to it. Do you remember the first black hole we ever photographed? It's in the Messier 87 galaxy, and while it appears small and charming in the shot, it's actually quite large. It is capable of consuming our entire solar system up to and beyond the Orion Belt. After discussing the alarming size of supermassive black holes, it's time to move on to the actual titans of the cosmos. The largest objects that have ever existed and are likely to exist in our planet are ultra-gigantic black holes, which have masses tens of billions of times that of the Sun. Their gravity gets so strong that they form quasars around them, disks that shine brighter than dozens of galaxies together. Remember, we discussed how supermassive black holes can't eat galaxies very well. These guys eat everything in their path, not just their host galaxies. OJ 287's ultramassive black hole has an estimated mass of 18 billion solar masses. It's so massive that another black hole orbits it. It could also easily house not one, but 3 solar systems, and now, finally, we've arrived to TON 618. The universe's greatest object, the all-powerful destroyer of worlds, a black hole that has devoured more than one galaxy. Its mass exceeds 66 billion solar masses, and it could hold 11 solar systems. The quasar at N618 shines brighter than 1 billion stars. Its brightness is so strong that it has reached us, even though we're 18 billion light years away. And the creepiest aspect is that this isn't even its true size. This is how the world looked roughly 10 billion years ago. TON 618 is too far away. Its light reaches us for a very long period, implying that what we see is how this black hole appeared before the universe was born. But we have no idea what it looks like now. But it's probably millions of billions of times larger than that. That's all for now. So, if you've satisfied your curiosity, give the video a thumbs up and share it with your friends. Or if you want more, click on these videos and stay on the facts for real videos.